Hello everybody and welcome to the Carlam Cymru revision sessions. My name is Alexa Jones and I will be presenting this session focused on the intermediate maths and numeracy GCSE. The session will last around 45 minutes. If you have any questions, please use the question and answer section within this live event and I will do my best to answer your questions. The session will be recorded and the recording and any relevant resources will be uploaded to the e-sgol website under the Carlam Cymru tab. Okay, so today we are going to have a look at upper and lower bounds and you'll need a calculator for the lesson today. So we're going to start off with a quick reminder and I'm going to ask you to find the area of this rectangle and to give your answer in meters squared. So we have one side that is 2 meters, but the other side has been given as 80 centimeters. Now, as this is a live presentation, I will only pause for a short time. So you will need to pause the video to try the questions and then start the video again in order to check your answers. So if you'd like to pause and try this one now, then I will pop the answer up just in a second. Okay, so with this first one, we've been asked to find the area of the rectangle in meters squared. So it makes most sense to change this 80 centimeters, first of all, into meters. And I know that 100 centimeters is equal to 1 meter. So 80 centimeters is less than 1 meter. It is 0.8 meters. The area of the rectangle, you multiply the two sides together. So we're multiplying the base by the height here. So I'm going to multiply 2 by 0.8 and that gives me 1.6 and my answer is in meters squared. So that was the area. I had to multiply the two sides together and we were finding the space inside that rectangle. Okay, for the next question then, I'm going to ask you to find the perimeter of this rectangle and to give the units of your answer. So you can choose whether you do this in centimetres or in millimetres, but can you please give the units of your answer? So if you'd like to pause the video and then try this one, and then start again as soon as you're ready to see the answer. Okay, so with this one, now we can choose to do this in centimetres, in which case I know that 1 centimetre is equal to 10 millimetres. So that means that 25 millimetres must be 2.5 centimetres. And the perimeter is all the way around the outside of this. So I've got 4 sides and I'm going to go all the way around the outside. So that would be 4, add 2.5 centimetres, add 4. Add 2.5 centimetres. So that would give us 13 centimetres. And I did need to give the units. There'll be a mark for the units if you're asked to give the units of your answer. If you'd chosen to do this in millimetres, then you would have changed 4 centimetres into 40 millimetres. And this would be 40, add 25, add 40, add 25. So that would be 130 millimetres. So that was perimeter. It was the distance around the outside. Now, the other skill that we need in order to answer the questions today is to be able to round. So I'm going to ask you to pause the video and just try and round each of these numbers to the nearest 10, please. Okay, so hopefully you've had a go at these. Now, 396. I am going to think about the 10 that is below 396 and the 10 above it. 396, the 10 below it is 390 and the 10 above it is 400. In the middle of those would be 395. So 396 would be approximately here, and that is closer to 400 to the nearest 10. 251. So the 10 below it is 250. The 10 above it is 260. In between those would be 255, and I've got 251 down here. So to the nearest 10, this one would be 250. And then finally, 825. So the 10 below this would be 820, and the 10 above this would be 830. And 825 then is exactly in the middle. And if you remember, if you are exactly halfway, exactly in the middle, then you round up. So here the answer would be 830. So now we're going to have a think about what is the smallest number that rounds up to 350 when you're rounding to the nearest 10. So to the nearest 10, our answers would be 340, 350, 360. And we've got to think about the numbers that would round up to 350. Well, 349, that's going to round up. 348, that is going to round up. And what we are looking for is the smallest number. So the smallest number here that's going to round up is 345. So 345 would round up, whereas if I had 349.999, then that one would round down to 340. And let's have a look at the next one. So what is the largest number that rounds down to 350 when you round to the nearest 10? Well, if you think about halfway between 350 and 360, that would be 355. And of course, 355 would round up. So a number that is slightly smaller than 355 would be 354.999 recurring. So you can show that with a dot on top of the 9. That's a difficult number to use. So for upper and lower bounds, what we do is we say that instead of using this 354.9999, we're actually going to use 355, even though 355 would round up to 360. For the topic of upper and lower bounds, we are going to use that number 355, just because 354.9 recurring is a difficult number. So upper and lower bounds then, the way that we find the upper and lower bounds, we start by dividing the accuracy by 2. Now, in the last questions we were looking at, we were rounding to the nearest 10. So to divide that, you would divide 10 by 2, and you would say, okay, you need to go up and down by 5. So you would subtract this number to find the lower bound. So you'd subtract 5 to find the lower bound, and you would add 5 to find the upper bound. And that makes a little bit more sense when you see it in an example. Okay, so the example says, find the upper and lower bounds of 350 if it has been rounded to the nearest 10. So first thing we've got to do is we've got to look for the accuracy. And the accuracy level here is it's been rounded to the nearest 10. So we're going to divide that accuracy by 2. And half of 10 is 5. Now, to find the lower bound, we are going to subtract 5 from 350. So I'm going to do 350 subtract 5. So the lower bound is 345. And 345, that's the smallest number that would still round up to 350. Then for our upper bound, we're going to do 350 add the 5. So that is 355. And this is the one that people usually have trouble with, because people know that 355 does actually round up to 360. But we use it because that number 354.999 is a difficult number to work with. Okay, so you are going to half the level of accuracy, and then you subtract it for the lower bound and you add it for the upper bound. So here's a question, or 3 questions for you. Can you please pause the presentation and try each of these? Can you please find the upper and lower bounds of these numbers if they have been rounded to the nearest 10? Can you pause the video and try these, please? Okay, so the accuracy level then. The accuracy is to the nearest 10. So we are going to take that 10 and divide it by 2. So we need to add and subtract 5. So for 90, our lower bound is going to be 90 subtract 5. So that one's going to be 85. And our upper bound is going to be 90 add 5. So that one's going to be 95. For 240, our lower bound is going to be 240 subtract 5. So that's 235. And our upper bound is going to be 240 add 5. So that one is 245. For this one, our lower bound is 3,200 subtract 5. So that is 3,195. And our upper bound is going to be 3,200 add 5. So that one is 3,205. So that's rounding to the nearest 10, but they don't always ask us these with an accuracy to the nearest 10. So examples, find the upper and lower bounds of the following. 600 if it has been rounded to the nearest 100. We take 100 and we divide it by 2 to get 50. So our lower bound is going to be 600 subtract 50. It's going to be 550. And our upper bound is going to be 600 add 50. So that one's going to be 650. 40 if it has been rounded to the nearest 5. Well, the accuracy here is the nearest 5. So I have to take 5 and divide it by 2, and that gives me 2.5. So for my lower bound, I do 40 subtract 2.5, which is 37.5. And for my upper bound, I do 40 add 2.5. So that one is going to be 42.5. Then 28 if it has been rounded to the nearest whole number. So our accuracy here is nearest whole number. Well, that's actually 1. So when we're talking about rounding to the nearest whole number, they're talking about rounding to the nearest whole 1. So I do 1, divide that by 2, and that gives me 0.5. So when I'm rounding to the nearest whole number, I need to go up and down by 0.5. So for my lower bound, I do 28 subtract 0.5, which is 27.5. And for my upper bound, I do 28 add 0.5, which is 28.5. Okay, so that's how the upper and lower bounds work. You're dividing the accuracy by 2, you subtract it for the lower bound, you add it for the upper bound. So here I have got some questions for you. Can you please find the upper and lower bounds of the following? 250 to the nearest 50, 4,000 to the nearest 100, 80 to the nearest 5, and 34 to the nearest whole number. Can you please pause the presentation, try those, and then start the video again when you are ready to see the answers. Okay, let's have a look at these. So for the first one, to the nearest 50. 50 divided by 2 is 25. So my lower bound is going to be 250 subtract 25, which is 225. And my upper bound is 250 add 25, which is 275. 4,000 to the nearest 100. Well, the accuracy is the nearest 100, so I divide that by 2, and I need to go up and down by 50. So I do 4,000 for the lower bound, 4,000 subtract 50, which is 3,950. And for the upper bound, I do 4,000 add 50. So that one is going to be 4,050. Next one, 80 to the nearest 5. So the accuracy is 5. I divide that by 2 to get 2.5. My lower bound is 80 subtract 2.5. So that is 77.5. And my upper bound is 80 plus 2.5. So that one is 82.5. And then this last one, it's to the nearest whole number. So if it's the nearest whole number, I do 1 divided by 2. Let me rub that out because I'm writing the wrong thing down. I'm writing the answer down without writing the question. So I am doing 1 divided by 2, which is a half or 0.5. So for my lower bound, I would do 34 subtract 0.5, which is 33.5. And for my upper bound, I would do 34 add 0.5. So that one is 34.5. Okay, hopefully you did well with those. Right, let's have a look at this then. Now, here's an example. It says a rope is 4 meters long, measured correct to the nearest meter. What is the least and greatest length of the rope? Now, this is the way that they're going to ask the questions in the exam. They are not going to tell you that it's an upper and lower bounds question. So these are the words that you need to look for. This word least and greatest, when you see those words, those are your clue that this is an upper and lower bounds question. I can see here that my accuracy is to the nearest meter. So that's to the nearest 1 meter. So with this, to the nearest 1 meter, if I do 1 divided by 2, that is a half or 0.5. So the least length of the rope, well, that's actually the lower bound. So it's going to be 4 subtract 0.5. So that is going to be 3.5 meters. That's the least. And then the greatest length this could be would be 4 add 0.5, which is 4.5 meters. You could have also done these in centimeters. So you could have chosen to make this 400 centimeters, and then you could have gone up and down by 50 centimeters to get 350 and 450 if you don't like working in decimals. Now, with this, the one that people get confused about is they get confused with the 4.5, because we know that 4.5 is actually going to round up. It's not going to round down. But this is an upper and lower bounds question, so we are going to use that 4.5 because it's a much nicer number than 4.49 recurring. And this is the number that you're going to need to use in the exam. You are going to need to go up and down by the 0.5. Okay, so let's try one of those. So here's a question for you. A bridge is 600 meters long, measured correct to the nearest 10 meters. What is the least and the greatest length of the bridge? Pause the presentation, try the question, and then come back when you're ready for the answer. Okay, let's have a look. So with this one, it's correct to the nearest 10 meters. So I do 10 divided by 2 is equal to 5. And for the least length, I need to subtract 5 from 600. 600 subtract 5 is 595 meters. And then the greatest length of this bridge is going to be 600 add 5. It is going to be 605 meters. Let's have a look at the next one. Okay, so we're going on to the past paper questions now. And it says Maya will be competing in a half marathon race. She uses a route for training that is 10,000 meters long, measured correct to the nearest 100 meters. Her first complete training run took 73 minutes, measured correct to the nearest minute. Complete the table below to show the least and greatest distance of her route and the least and greatest time of her training run. Okay, so with this one, now if you want to have a go at this one yourself, then pause the video. If not, then let's have a look at this one, and I've got another one for you to try in a minute. The first one, it is 10,000 meters long, this route, correct to the nearest 100. So this is the accuracy, is 100. I do 100 divided by 2, which is 50. And then to work out the least value, I need to do 10,000 take away 50. And 10,000 take away 50 is 9,950. And then for the greatest, I would do 10,000 add 50. So that one would be 10,050 metres. Then the time. The first completed training run took 73 minutes and it was correct to the nearest minute. So that's 1 minute. 1 divided by 2 is 0.5. So for this one, I need to do 73 subtract 0.5 for the least amount of time. So that is 72.5. And I need to do 73 add 0.5 for the greatest amount of time. So that one is 73.5. Okay, I've got one of those for you to try now. So let's have a look at this one. Asif drove his car 270 miles, measured correct to the nearest 10 miles. He used 28 litres of fuel, measure correct to the nearest litre. Complete the table below to show the least and greatest distance that Asif could have travelled and the least and greatest amount of fuel that he could have used. So if you pause the video and try that one and come back when you're ready to see the answers. Okay, let's have a look. Now, the accuracy on the miles is to the nearest 10. 10 divided by 2 is 5. So this is going to be 270 subtract 5. So the least distance is 265. And then 270 add 5 for the greatest distance. So 275. 28 litres of fuel correct to the nearest litre. That's the nearest 1 litre. So 1 divided by 2 is 0.5. So this one is going to be 28 subtract 0.5, which is 27.5. And then 28 add 0.5 for the other one. So 28.5 litres for the greatest value. Hey, I've got one more of those for you now. It says, a flower shop takes delivery of a large tray of daffodils. A label on the side of the tray states the total weight of the daffodils is 8 kilograms, correct to the nearest kilogram. The height of each daffodil is 20 centimetres, correct to the nearest 10 centimetres. Complete the table below to show the least and greatest total weight of the daffodils delivered and the least and greatest height of the daffodils delivered. So pause the video, try that one, and then come back when you're ready for the answer. Okay, so first one, the weight. It's to the nearest kilogram. So that's the nearest 1 kilogram. 1 divided by 2 is 0.5. So I need to do 8 subtract 0.5. So the least weight is 7.5 kilograms. And then I need to do 8 add 0.5. So the greatest weight is 8.5 kilograms. For the height of the daffodils, it's correct to the nearest 10 centimetres. So I divide that accuracy by 2 to give me 5 centimetres. And I need to do 20 subtract 5 for the least, which is 15 centimetres, and 20 add 5 for the greatest, which is 25 centimetres for the greatest height of the daffodils. Let's have a look at the next one. Example. 2 large bags are filled with decorative pebbles. Bag A contains 160 kilograms, measured correct to the nearest 10 kilograms, whereas bag B contains 157 kilograms, measured correct to the nearest 1 kilogram. Each bag actually contains the least weight of pebbles that its label allows. Which bag contains the least weight of pebbles? Now with this, they are talking about the least, but I'm going to work out the greatest and the least, because in a lot of these questions, if you work out the greatest and the least, you have more chance of getting the marks if you make a little mistake a bit later on. So for the first one, I'm going to look at bag A. It's to the nearest 10 kilograms. So I divide that by 2, and I now know that I need to add and subtract 5 kilograms. So I am going to do 160 subtract 5, which is 155 kilograms for the least. And then I'm going to do 160 add 5 for 165 kilograms for the greatest. Then I look at bag B. Now this one is to the nearest 1 kilogram. So I do 1 divided by 2 is 0.5. So the least this bag could be is 157 subtract 0.5, which is 156.5 kilograms. And then the most this could be is 157 add 0.5, which is 157.5 kilograms. Then it says, each bag actually contains the least weight of pebbles that its label allows. So I now know that I'm talking about the smallest, the least of these. So that's 155 kilograms on bag A. And on bag B, we've got 156.5 kilograms. And then it says, which bag contains the least weight of pebbles? Well, bag A has 155 kilograms and bag B has 156.5 kilograms. So we need to answer the question. So which bag has the least weight? Which bag contains the least weight of pebbles? So I need to say bag A has the least weight of pebbles. You always need to double check that you're actually answering the question. So even though you've done all the workings, you do need to tell the examiner that it's actually bag A. So you do need to just go back and check, have I answered the question? All right, let's have a look at another one of these. So it says 2 boxes are stacked on top of each other. The height of each box is 6 centimetres, measured to the nearest centimetre. Explain why these 2 boxes may not fit in a space that is 12 centimetres high. So if you'd like to pause the video and try that one, and then we will come back and look at that one when we're ready. Okay, let's have a look at that one. Right, so we have got each box is 6 centimetres, measured to the nearest centimetre. That is the nearest 1 centimetre. So I divide that by 2, and I know that I need to add and subtract 0.5 centimetres to each of these. So the least height of a box is 6. Subtract 0.5, so that is 5.5 centimetres. And the greatest height of the box is 6 add 0.5, which is 6.5 centimetres. So the question is asking us, explain why these 2 boxes may not fit in a space that is 12 centimetres high. So what we're thinking about is we're thinking about these 2 boxes, one on top of the other, and why might they not fit? And if you think about it, if this one is 6.5 and this one is 6.5, then 6.5 add 6.5, that's 13 centimetres. So the 2 boxes stacked together, they might not fit. It says explain, so I'm going to have to write a sentence to explain that as well. So I need to say that the 2 boxes could be 13 centimetres tall. So they might not fit in a 12 centimetre space. Okay, you've got to watch out for that word as well, this explain word. So if something asks you to explain, then you're usually going to need to write some sort of a sentence at the end to explain what you've decided. But you will normally need to show the workings as well. So just looking at this and saying, well, 2 of them wouldn't fit, that's okay. but if you've got the workings there to prove it as well. So you would have to show that 6.5 add 6.5 comes to 13, which is larger than 12. You need to do both of those things in order to get all the marks in that question. Let's have a look at the next one. It says, the lengths of the sides of a rectangle are given as 24 centimetres and 15 centimetres. Each measurement is given correct to the nearest centimetre. Calculate the difference between the greatest possible perimeter of the rectangle and the least possible perimeter of the rectangle. Now, each measurement is given correct to the nearest centimetre. That's the nearest 1 centimetre. So 1 divided by 2, again, is 0.5. So for these, the 24 centimetres, I need to subtract 0.5 and say that would be 23.5. And then add 0.5 and say that is 24.5. So this one could be at the least 23.5 and at the most 24.5. Then turning to the 15 centimetres, I've got to add and subtract 0.5 from 15. So this one could be between 14.5 centimetres and 15.5 centimetres. So I've worked out the different measurements for each of these, the upper and lower bounds for the 24 and also for the 15. Then it says calculate the difference between the greatest possible perimeter and the least possible perimeter. So I'm going to need to work each of those out. And with these, quite often, if I'm asked a question like this, I will just sketch it because it helps me to think about what I'm doing. The greatest possible perimeter of the rectangle is the distance around the outside. Now, the rectangle that we started with would have been 24 by 15, like this, and we've got to think about the greatest. So the largest this could be is 24.5, and this one would also be 24.5, and then the largest this would be 15.5, and the largest this one would be 15.5. So for this one, I'm going to need to add these up. So I'm going to do 24.5, add 15.5, add 24.5, add 15.5. Let me just work that one out because I've dropped the sheet that's got all my answers on it. Right, so 24.5 add 24.5 add 15.5. So that one is going to give me 80 centimetres. And then we need to look at the least as well. So, pardon me, for the least possible perimeter, well, that's if we're using all the smallest values. So the smallest values were 23.5 for the longer side, and then it was 14.5 for the shorter side. So I'm going to add those up, 14.5, 23.5, add another 14.5, add another 23.5. So let's add those up, 14.5, 23.5, 14.5, add 23.5, and that gives me 76 centimetres. And then the question says, calculate the difference between the greatest and the least. So the difference between those two numbers, I need to subtract them. 80 take away 76, the difference is going to be 4 centimetres. Okay, let's have a look at the next one. So here's a question. A rectangle measures 38 centimetres by 26 centimetres. Each measurement is correct to the nearest centimetre. Calculate the least possible area of the rectangle. Okay, can you please pause the video and try this one? Okay, let's have a look at the answers to this one. Right, it's 2, the nearest 1 centimetre. 1 divided by 2 is 0.5, so I need to go up and down by 0.5 with each of these, so add and subtract 0.5. So the 38 will be between 37.5 and 38.5, And then the 26 is going to be between 25.5 and 26.5. Area, we need to multiply the two sides, the base and the height together in order to find the area. And they want the least possible area. So for the least possible area, it's going to be the least if I'm using the smallest numbers possible as I'm multiplying them. So that would mean that the height would be 25.5, and then my base here would be 37.5. So I am using the two smaller numbers here. Multiplying those together, 25.5 multiplied by 37.5. Let's work that one out. 25.5 multiplied by 37.5. That one is 956.25. And these were in centimetres, so area then will be in centimetres squared. Let's have a look at the next question. Right, okay. So this one, let me just try and get that at the right height. Michelle owns a cafe. She stacks coffee mugs as shown in the diagram below. So they've drawn us a picture here, and it says Michelle measures the height of each coffee mug as 12 centimetres, correct to the nearest centimetre. Each stacked coffee mug creates 4 centimetres extra height, correct to the nearest centimetre. Michelle knows that the vertical height between the two shelves is exactly 39 centimetres. So the space she's got to put these cups in is exactly 39 centimetres. Can Michelle be certain that she will be able to place one stack of 7 coffee mugs between the two shelves? Give a reason for your answer, and you must show all your working. Now, if you want to, you can pause the video and you can try this one. I'm going to carry on with this one now, and I've got another one for you if you would prefer just to listen to it rather than try this one. Okay, so what have we got? We have got a stack of coffee mugs, and they want to know about 7 coffee mugs. So they're asking us here about 7 coffee mugs. So we need to think about what we're actually going to be able to see. So if there are 7 coffee mugs, I'm going to be able to see the whole of the first one. And then I would have 6 where I can only see part of them. So I've got 1, 2, 3, 4, 5, 6. So here I would have a stack of 6 cups, but I would also have this first cup. This is my 7 cups altogether. Now I've got to think about the distances that these could be. So I've got to think about what each one could be. The height of each coffee mug is 12 centimetres, correct to the nearest centimetre. 1 divided by 2 is 0.5. So this one going up and down 0.5, it's going to be between 11.5 and 12.5 centimetres. Each stacked coffee mug creates 4 centimetres, correct to the nearest centimetre. So again, this is 1 divided by 2 is 0.5. So this is going to be between 3.5 and 4.5. Now, can Michelle be certain that she'll be able to place one stack of 7 coffee mugs between the two shelves? Well, if she puts the small ones in, she's got a fairly good chance. We'd have to do the numbers, but she's got a fairly good chance of being able to put them in. So the ones that we're worried about the large ones. If these are all at the upper bounds, so if this first cup is 12.5 centimetres, and if the other 6 cups are all at the 4.5, then that's the case whereby it might not fit. So what we need to do is we need to work out the first cup at 12.5, and then we've 6 more cups at 4.5 and see how that works out. So 1 cup at 12.5, well, that's just 12.5. Then I'd need to do 6 lots of 4.5, and that is 27 centimetres. And when I add those together, I find that actually that's going to come out to 39.5 centimetres. So 39.5 centimetres. I've got to make sure that I answer the question. And it says, can Michelle be certain that she will be able to place one stack of 7 coffee mugs between the 2 shelves? Well, the answer is no. And that is because 39.5 centimetres is greater than the 39 centimetre gap that we might have. So we just need to say no, she can't be certain, because it works out to 39.5 centimetres, and that is greater than the exactly 39 centimetre gap that she has. Okay, I've got a question for you now. So it says a baker requires 825 kilograms of flour. She buys the flour in bags that contain 36 kilograms of flour, correct to the nearest kilogram. Is she guaranteed to have enough flour if she buys 23 of these bags? You must show the calculations needed to decide your answer. Can you please pause the video and try this one, and then come back and we'll see how you've done. Okay, let's have a look. Right, so 36 kilograms of flour to the nearest kilogram. 1 divided by 2 is 0.5. So I have to add and subtract 0.5. This flour is going to be between 35.5 and 36.5 kilograms. Is she guaranteed to have enough flour if she buys 23 of these bags? Well, with this, if I think about 23 of the smaller bags, that's the one whereby she might possibly not have enough. So if I do 23 multiplied by 35.5, I am getting 816.5 kilograms. So no, she doesn't have enough. Okay, so is she guaranteed to have enough flour if she buys 23 of these bags? Well, no, she isn't, because if she buys 23 of the smaller bags, so 23 of the smallest bags, then she wouldn't have enough. And sometimes with this, if you are not sure with a question, it's best to do both sets of calculations. So sometimes it's worth also doing 23 multiplied by 36.5. So 23 multiplied by 36.5, and that one is 839.5 kilograms. Quite often with these, I suggest that people do both sets of calculations, because then you've got more chances of actually having the calculation that you need there and being able to answer the question. So it's often worth doing maybe more calculations than you think you need, just so that you can have a look at them and make sure that you get the right answer. Okay, so let's have a little look at the things that we need to remember from this lesson. So the things that we need to remember. The most important one is to remember to divide the level of accuracy by 2. So if something is to the nearest 10, you need to add and subtract 5. If it's to the nearest 100, you'd add and subtract 50. If it's to the nearest 1, you'd add and subtract 0.5. You take that level of accuracy and you divide it by 2, and then you add and subtract it to the original number. So we're adding for the upper band and we're subtracting for the lower band, but they're not going to ask you about bands in the exam. So in the exam, the words that you need to watch out for is you need to watch out for these words least and greatest. And if you see those words, that needs to be the clue to you that this is the upper and lower bounds question. I've got to take that accuracy and divide it by 2. Now, when you are combining bounds, and by combining bounds, I'm talking about things like stacking boxes on top of each other, some of the more complicated questions. There are some more on the worksheet that we didn't do, so I'm going to leave those on so you can carry on with the worksheet and have a look at those, and I'll put the answers on as well. When you're doing the more complicated ones, work out the least and greatest values. Don't just look at it and say, oh, I think this is about the least values, I'm just going to work those out. always work out the upper and the lower bound, because that gives you the absolute best chance of earning the marks in the exam. Okay, well, thank you very much for joining us today, and hopefully you'll join us again next week. And next week we will be looking at writing numbers as a product of their prime factors. There we are, that took me a minute to say it. So next week, same time, we'll be writing numbers as a product of their prime factors. I hope to see you then.